So we're going to be discussing about cellular awareness, how to spring clean your cell. This is a combination of two different presentations that we are covering recently. So we took the salient points from one and the other one and put it all in one nice little hour presentation for you. So one of the first things that we want to do is look at our cells and our detoxification power, detoxification ability. So our body works intrinsically, so all the systems, they're not separate, they all work together. And one of the things we're going to be exploring tonight will be energy. So if we imagine body like an electrical company, chemical factory, so all the transportations, all the reaction, they all happen simultaneously. And in a way, the workers are really, really important because they drive these specific operations. So one of the challenges that we have nowadays, we'll expand in a minute, and I have amply expanded in our current tool, is that our cells, in order to function well, they need to have the least amount of environmental challenges as we can from the environment. So they're constantly trying to maintain balance and keeping conditions adaptable. And these cells produce, obviously, debris, products that are part of a natural way of cell functioning. And these, I tend to call them endotoxins. Whereas the toxins that come from outside, I call them exotoxins. So this cellular waste has to be removed. If you imagine like a garbage in your house and you accumulate the garbage before taking it out of the bin, if this gets out of hand, eventually you're going to step on it or start to impact how you actually move in the house. So when these systems tend to be heavily challenged, these byproduct can potentially inhibit function and in some cases become toxic altogether. So when we see patients that have a certain degree of cellular toxicities, we are very likely to see certain symptoms. One of the ones that is probably one of the most important to me is energy. Energy, first of all, because everyone understands energy, everyone understands weight gain or weight loss, and we can be asking questions around these two, around different types of symptoms, and we can gather a lot of information because anyone can, we can even like mime it in a way. So how's your energy? Is it really good all day, or does it go this way, or does it go up and down? So we have a direct insight of how the body is performing certain reactions. We can't really make assumptions or specific assumptions on things that how these will go down to a certain pathway, but definitely we know that perhaps cellular removal of toxic waste may be inhibited. We look at reacting quite heavily to environmental toxin, inflammation, speed of thinking, skin, one of the organs that is easily accessible to our eyes. Premature aging, you can see my white hair, that was the birth of my son. My hair was all black, and then my son was born, and they became all white. So hydrogen peroxide had a massive hit. This is probably endotoxins not removed properly. So, and then we go into things that are more specific, like fertility issues, tendency to depression, or not reacting very well to environmental challenges on the psycho-emotional level. So we're going to dig into the cells a little bit more. So we know that our body has many, many, many cells, and we have fossils evidence that reveals that these cells existed for 600 million years. And we look at these tiny, minute particles that have an incredible amount of power on our well-being. So the cells, there is a book called Life, The Journey of a Mitochondria, and I strongly recommend it because it's the story of how mitochondria was integrated into a cell for a mutual benefit. So primordial cells said, oh, I like you, you make energy, and mitochondria said, oh, I like you because you create protection, and this is how potentially mitochondria were integrated into a cell to form a cell as we know it, or eukaryotic cells. So in order to survive at high density, the cells had to create a structured environment, and this structure was helped and supported by our physiology, and eventually certain organization of the structure started to have a specific function. So, for example, like an organ. And there is a pattern of differentiation that became embedded in our genes of every cell. We have three main genetic materials. The first one is mitochondrial DNA, which is abbreviated as mtDNA, our DNA, and then obviously we have the DNA from our microbiome. So there is a strong epigenetic interactions that can affect all of them. So human cells, there are different types. There are many, many types, about a couple of hundred, and these can be divided into four main groups: somatic, gamete, germ, and stem cells. So as you can see from the pictures, they tend to develop in slightly different functions. And if you think about, for example, certain diseases like endometriosis, one of the theories behind endometriosis is actually related to cellular waste removal, to the point that the wrong type of cell actually starts to grow in the wrong area, meaning that sex hormone sensitive cells may be part of an organ that in a way should not be actually sensitized to that. So in a way the DNA is the same, epigenetic control is the same, yet the cells develop with a different function. In fact, this can explain the theory through that will actually state that eye cells, or eye cells in general, are starting to be responsive to certain sex hormones. So eukaryotic cells this is the typical picture taken from, I'm sure you've seen this picture before, but it's contained by, is made up by nucleus, endoplasmic reticulum, you have Golgi apparatus here, mitochondria. Mitochondria, the quality of the mitochondria is generally given by the mother alone. But the number seems to have more affinity with the father, and although the mitochondrial density, there are environmental factors that can actually change that mitochondrial density. So basically the number of mitochondria within the cells. We'll see that certain time restricted feeding or fasting or exercise can dramatically increase this number. In addition to that, we have ribosomes, which are molecular factory containing RNA, so the stuff that actually reads the DNA, like in a strand when it's split, that is read and producing proteins. And then lysosome, containing enzymes that kind of liquefy, break down through free radicals the cellular waste. So it's a very, very well organized structure. So let's have a look at how cellular waste is made up and potentially removed. So cellular respiration is the process, to summarize, is the process by which we generate energy. So this generates CO2, so carbon dioxide, and water as a waste. Obviously generates energy. So CO2 is excreted by diffusion to the bloodstreams, where it binds to hemoglobin and then carrying out an exhale. We have experience of that every time we are kind of out of breath. This is potential, or if you breathe in a paper bag, you have an accumulations of one gas instead of the other one. So these are direct examples of, gases homeostasis between oxygen and CO2. And obviously we have water, and water diffuses out of the cells into the bloodstream, where it is secreted from the perspiration, obviously, and then water vapor in breath, urines, and kidneys. I seem to remember that we can actually exhale up to 400 milliliters of water, whatever is the norm. I don't know what the norm, I don't know norm but it's still, what I'm trying to say is actually we breathe out quite a lot, and we know that when it's cold and we breathe onto a glass, there is a strong condensation coming from our breath. So the other one is an anaerobic respiration, which generates a range of waste products, including nitrates, succinate, sulfide, methane, and acetate. So we know the anaerobic respiration, for one, is a lot more expensive for the body to produce. So if we consider the difference between aerobic and anaerobic is time. So how long does the body has to be able to burn the fuel to give a certain quantity or value of energy? So if we have enough time, therefore enough oxygen, then we can use aerobic respiration. And in other cases where, for example, we are sprinting or doing anything that will require a short burst, then we will be using anaerobic respiration. So this generates a lot of cellular waste, so definitely a lot higher. You can see here the main substrate actually entering, actually not the main ones, I put just the fatty acids, glucose and ketones. I purposely left out amino acids. They would follow slightly different pathway, but then eventually they can still enter. I find mitochondria amazing because regardless of the substrate, they can get energy out of it. So we have our usual glucose with brain functions and muscle function between GLUT1 and GLUT4. Insulin activates this, so any form of insulin resistance, we can see the glucose level will be higher. So if someone becomes insulin resistant, and this is where insulin is, means that this message is not carried out efficiently or inhibited by inflammatory response, intracellular inflammatory response, not on top of extracellular inflammatory response. And then because glucose cannot flow inside the cell, is accumulated outside the cell, and we know this as hyperglycemia or subclinical hyperglycemia. Slightly different with long-chain fatty acid or fatty acid will be fatty acetyl coenzyme A, and eventually acyl coenzyme A going through beta oxidation and then eventually entering the electron transport chain. Now, ketones follow a slightly different fate because they are produced by the liver, unless they are exogenous. There are some supplementation company that would provide exogenous ketones, which, if they're not used correctly, I personally find that in some cases could be quite dangerous because you don't want to end up with high ketones and high glucose. However, for most of people, especially sport people, I find them safe and actually still beneficial, even though there is high glucose level, but the person has to be monitored, efficiently and pretty well. So ketones enter directly the mitochondria and can be burned very, very efficiently for fuel. The only limitation is if someone trains at very high levels and continues that, then ketone needs a little bit more time to be burned, so perhaps they may run a bit short. So we need a certain amount of glucose, as I have experimented amply on myself. You can see here 4 complexes right at the bottom with NAD, H, FAD, H, and then the other 2. There is a 5th one which takes it out. So there are 5 complexes. So we know that when the demand of energy is very high and glucose is oxidized, eventually lactic acid is produced. And this is produced from basically our respiration. If we have enough time, lactic acid isn't produced. If there is enough oxygen there for time, then obviously there is an accumulation. And this is recycled by a cycle called the Cori cycle, and people that train and often generate lactic acid, or people that are ketogenic and train, or people that are fasting, there seems to be a train of thought that highlights the fact that Cori cycle can be upregulated, so they can still, rather than just burning fatty acid, what they do, they basically recycle lactic acid much quicker. So lactic acid tends to accumulate, and we know the little burn if we sprint or post-training, or unfortunately for some people, lactic acid accumulation can be part of everyday life. So if mitochondria don't produce enough energy, or they're substantially challenged from a physiological perspective, then there is an accumulation of lactic acid, and this seems to be thought one of the underlying mechanisms behind fibromyalgia, chronic fatigue, and PVFS, so post-viral chronic fatigue syndrome. And many cofactors play a very important role in this. And one of the things that definitely want to make sure to have on top of the usual B vitamins and certain minerals is definitely have a good levels of magnesium and malic acid play a role in this. So many times people that seems to have this accumulation of lactic acid, if you look at the Krebs cycle, malate enter in one side of the cycle and is one of the quickest routes to generate ATP. So people normally tend to feel a little bit better straight away, and I'm talking straight away within, within not so much hours, but tens of hours. So that's normally a pretty good result for that. So, as mentioned, there are a few nutrients that are really, really important for cellular energy. We have glycolysis and acetyl coenzyme A, and we have listed here for you the most important nutrients. I'm sure that there are more, in actual fact, I am sure that there are more, but mainly the one that definitely the body cannot go without. You can actually see that, for example, glutathione, B1, B2, B3, B5, that actually show up in the first two very, very well. Electron transport chain, this will have sulfur, iron, copper, CoQ10, selenium, magnesium, and again, glutathione. The disruption between the levels of glutathione and SAMe physiologically in the body can lead to complex 1 inhibition. So within complex 1, if you remember from one of the previous slides, NADH donates an electron, is reduced to NAD. If someone were to supplement an NADH and feel worse, then I would definitely look at the glutathione level, SAMe and SAR level, and potentially indirectly methylation as well. So as far as antioxidant support, therefore, we look at CoQ10, glutathione again, NADH, selenium, ALA, as in alpha-lipoic acid, and a collection of phytonutrients that allows the person to have a very good protective supporting effect. Transporters, if someone, especially for people that are embracing a high-fat diet and or ketogenic diet, someone can be high fat but not ketogenic, still probably they would benefit out of using carnitine, phosphatidylserine for membrane support, and electrolyte minerals. Actually, let me specify something. Looking at the work of Patricia Kane, Shida Puria, and etc., there has to be a ratio between phosphatidyl groups and function. So serine is more for function, for certain function, and then you have obviously phosphatidylcholine, phosphatidyl ethanol amine, and these have to be present in a certain ratio. If people are, for example, really ill, I was having a chat with Lucille Lida and one of the recent conferences, and she mentioned that if people are quite poorly, especially in the area of Parkinson, they may have to be really careful with strong supplementation of certain groups. I do seem to understand it's not on one of my area, but just in case, I decided to mention it, so you may do some research out of your own back. So yeah, so Biocare has these products. The one I tend to use the most will be NADH Perform Intense in the MitoGuard. When I train and I know I'm going to be in a kind of anaerobic, mixed aerobic state training, then I use both. I use a combination of MitoGuard and Perform Intensive, always making sure that I have enough methyl groups through 5-MTHF and obviously methylcobalamin, or even better, methylcobalamin. NADH, normally people feel like a little pickup because complex 1 kind of kicks in, except, as mentioned earlier, if he's not able to regenerate NAD because of the levels of glutathione and some E. So maybe at times we need to reduce supplementation, especially if we took some substantial environmental changes. This is one of the things that, this is the case history I'm going to cover in the US in a month's time at ShakeOn 16, which is really, really interesting because is actually looking at my mistake in not actually dynamically changing the supplementation as I improve the environment a lot and I improve all sorts of things, so therefore the supplementation got in excess and I started to have loss of functions in other areas. So cellular turnover, body produces 25 million new cells per second. This data absolutely blows my mind. So our cell continuously are building messages, and these will carry out single task and then eventually discard them. So this sounds very wasteful, but when the body does something, there is a consequence. If the body produces something, then it has to do something with it. It will have to dispose it. It will have to break it down. It will have to do. It has to be recycled in some ways. So this is what we tend to look at cellular waste. And some of the pathways that I try my best to support would be autophagia and ubiquitin system. These two degradation pathway function in a highly coordinated manner in order to maintain the cellular waste very, very efficient. So autophagia, I'm sure you must have heard the word. This is eating it yourself. But more than eating yourself is actually eating the waste produced by yourself. This can be a really, really interesting process because autophagia tends to reduce the level of protein, because autophagia also recycles certain proteins and certain amino acids. The body is amazing because the body is one of the most complex machines. Regardless the amount of money someone is going to make in their lives, their body is probably the one that will make us the richest. And one of the things that keeps amazing me about the body is not only the maintaining of the homeostasis, so the balance, but in addition to that, how efficiently can regenerate tissue and regenerate waste disposal in order to get benefits. So trying to get something out of nothing. So autophagia utilizes organelles called lysosome, and these will eventually end up in disposal units. So they make, imagine like a cellular stomach containing enzymes that will eventually digest protein, pathogens, including viruses, bacteria. And one of the good things is that these will keep recycling under certain conditions. Eventually, as mentioned, some of them would be recycled into energy, building blocks, and other vitally important things. So autophagy, in a way, has two major roles. So the first one will be cellular quality control and provide alternative energy source. Some time ago, I used to mention different quantities for protein requirement, for example, and combining ketogenic applications and intermittent fasting, both of them which, to some extent, enhance autophagia, I have estimated, and other researchers have estimated pretty much the same, there is a substantial 30 to 35% reduction in protein requirements, which is a substantial reduction. So this is actually down to a recycling of these proteins. So the effects in any autophagic degradation system are normally linked to disease, pathogenic expression, and obviously aging, leaving to the side also the potential epigenetic control, which we are not discussing here today. So once that things have got broken down, protein can become distorted, causing, in a way, loss of function, or the function in a certain organ is not carried out correctly. And in these scenarios, the cellular molecule called ubiquitin binds to obsolete protein in a way like signaling that these have to be dismantled or disassembled and have to be processed. So if that happens efficiently, the proteins are then removed, not only efficiently but also effectively, and proteasome will digest them and make them usable in different other ways, including eventually having peptide fragments. So we mentioned earlier about exotoxins. So we live in an environment where we are constantly challenged by chemicals. I was reading a piece of research, I can't remember actually the source on top of my head, but I mentioned this in the last talk. 70% of UK residents would have Roundup residues in their urines. So let's assume it's not quite fully true, or the source was, okay, the point is through urines, and we see this in, for example, in DNA adducts, so things that stick to the actual DNA, so even if someone doesn't have a SNP, it will actually impair function of that specific area of the gene. So if DNA adducts are affected, so if someone would have certain DNA adducts, normally are chemical from the environment. And we find, obviously we test only people that are not well, so that's the reason why virtually everyone we test, apart from a couple of cases, have tested positive for chemical DNA adducts. Dr. Sarah Myhill, I think, uses the same test regularly to actually see what are the implications. So for some of these chemicals, we don't actually have a specific favorite liver detoxification pathway. So many of these chemicals are fat soluble and can potentially bioaccumulate in our body, generating all sorts of disruptions. So one of the things that we try to support our best, as I mentioned earlier, is actually methylation. So primary method for removing toxins, not only methylation as we know in the methionine pathway, but actually methylation in general, even as a form of detoxification. So imagine like tagging toxic substances and then altering them in some way in order to allow the body to identify these toxins and then safely remove them from our body. And when this methylation cycle isn't working efficiently or isn't working well, then this is when we start to have a substantial challenge into our immunity. So normally we need to find a good balance between methylation. In the past, at the start, I used to mention hypomethylation and hypermethylation. Actually, if someone has too many methyl groups, in a way, certain symptoms will still be of poor methylation. So I think it's very important to make the distinction of saying providing too little methyl groups through diet, and supplementation. To me, diet is always first. The basics are always first. Or providing too many methyl groups, they normally get stuck in a slightly different area, but yet the result is still the methylation is not working well. That is one of the things that I have overly simplified, but I hope this one gives the idea. So when methylation cycle is not working well, body is unable to detoxify properly, and this will produce cell-mediated immune responses. Can go all the way to create a mitochondrial cell danger response. Once again, there is a lovely book called Life, the path of mitochondria. I'll see if I can mention it later, or ask Chris to put it in the resources later. So folate is 5-methyl tetrahydrofolate, or 5-MTHF, is a key substrate within the methionine cycle. Also is a good buddy with B12, methylcobalamin. So that's the reason why we want to use a combination of both. I personally, once the person has addressed the lifestyle, so first of all, green leafy veg, looking at the sleep. So there is no point to me in starting to design, very fine-tuning supplementation unless the major things, the ones that impact the most, have been addressed. But having said that, once the person has integrated some of the changes for them to feel better, and then still running a bit shorter, then looking into supplementation is very advantageous. And I tend to run 3, 4, 5 weeks after the person has implemented those basic changes, a functional test. So functional test, we look at, for example, a full methylation panel, so where we have all sorts of markers that are helping us to understand in which area we can get stuck. So genes do not tell us what's happening in the blood, and blood does not tell us the predisposition. We can have ideas, I understand, but we can't take this as per true. So as a last resource, if everything fails and the cell has no other option to remove the waste, this is when we started to find the protein debris will eventually start to aggregate. So one of these examples is amyloid polypeptide, which have normally been associated with pathology for more than 20 serious diseases, found in pancreas, in type 2 diabetes, found in brain, in Alzheimer's. So when the body is in danger, it tends to accumulate fat. And I believe that the primary reason for that is to try to promote inflammatory response. Bear in mind that fat cells are not inert. Obviously, fat cells are very, very active. And when the body is struggling to try to repair certain tissues, then one of the processes that can support inflammatory response, as a primary drive and or as a consequence of, is fatty acid accumulation. So this is where studies have shown that the production of amyloid is associated with mitochondrial dysfunction and consequent generation of ROS, or free radicals, as we know them. So we look now at DNA. So I love sometimes when I hear people, oh, I think I'm a bit inflamed and or I'm having a drink, so I'm having antioxidant now. Antioxidants have to be in situ. So by the time that the food or the supplement is digested and hasn't created a healthy baseline, then probably we missed that boat. We missed that train. This reaction happens in milliseconds, and there's a constant cascade of reactions going from radical to oxidized, radical to oxidized, radical to oxidized. And mitochondrial energy production requires oxygen to convert fuel molecules into carbon dioxide, as we looked at earlier. And oxygen is also a very, very powerful reactant and can disrupt cellular function in a form of free radicals. So eventually, if we look, for example, at DNA, double-stranded DNA breaks represent a real problem for the cells, because also it can be very disruptive for function, but it is very hard to repair. and this can affect the ability of the cell to do all sorts of function. And one of them is obviously producing energy. So hence at the very start, when I ask people, how's your energy, and can you remind me what is your energy like, then we know if this is always flat, so then to me that is quite substantial. If they wake up tired and takes a long time to go, they run for something, for the bus, and then they feel drained for a long time, that normally means that potentially this process is actually involved. So eventually that can contribute to inflammatory response. Inflammatory response has an effect on the whole body. And for example, my area of research now is metabolism of glucose and ketones, and inflammation alone, even during fasting, can raise glucose levels. So poor night's sleep, for example, raises glucose level. There are some really, really interesting studies on insulinogenic effect and glucose and hyperglycemia. So reactive oxygen species are one of the major sources of DNA damage. So fortunately, our body has an intrinsic system of antioxidants that can buffer some of these free radicals. So our cell maintain complex system of antioxidants, including catalase, glutathione, peroxidase, superoxide dismutase. In addition to that, we have also other type of antioxidants, for example, like vitamin C, vitamin E, vitamin A, and etc. Now, many of these still contribute to, imagine like an overall levels of antioxidative assets that we have. So if someone is well nourished, has the basics right, plenty of color, you know, the rainbow, but not the Smarties rainbow, the proper rainbow, the fruit and veg rainbow kind of thing. I mentioned fruit and veg, not the same category, but two separate ones. So just in case I freak out all my keto patients and clients. Now, glutathione is also important for regulation for the nitric oxide, and is also used, I mean, if you look at a pathway planner and you look in how many different areas glutathione is involved in the cycle, or also recycling other components, one of them is also DNA synthesis, repair, protein synthesis, prostaglandins, endless function. So glutathione improves the activity of important liver enzymes. They also detoxify more toxins. If someone is starting to gain a good degree of health and is starting to produce a good level of glutathione, normally they are less susceptible from environmental changes, including more toxins. Interestingly, towards the back end of last year, I had 7 cases in a row where we strongly suspected mold as one of the problems. Testing in the UK, I'm not aware of something that is very highly specific and precise enough to make certain decisions, but through questioning, so for example, how the person reacts in certain environment, if you are in a stressful environment, yet is a different environment that you know that is dry rather than humid, do you feel the same? So you can kind of source the questions and you know, based on the answer, you may want to take actions on that. So the antioxidants for cellular health obviously is a combination of. Some of the most important one will be OPCs, or oligomeric proanthocyanidins. Unless I want to maintain inflammation, so for example, if I train and I want to make sure that my tissue will rebuild in the shortest length of time, then I reduce my supplements and the anti-inflammatory effect of these supplements. I had a lovely conversation, actually I think it was a Facebook conversation, I can't remember, with one of my colleagues at DNA Fit called Craig Pinkering, ex-Olympian. And we kind of both agree. Actually, was reading one of his articles, actually, yeah. And it's really, really interesting because if you provide very high levels of antioxidants, and that can potentially inhibit inflammation, therefore inhibiting recovery. So If the inflammation is healthy and is monitored and is beneficial, then in that case, I would provide a baseline, possibly from diet, and then with an addendum of supplementation if it's needed to top it up. In my own little world, in N=1 and then N=5, I did some experimentation providing very high doses of antioxidant post very high anaerobic muscle tissue breakdown, and normally was 1 whole extra day extra for recovery in 5 out of 6. So that is considerable. We tried, stopped it, tried again without, tried again with, tried again without, so it was a total of 3 times. Pine bark, production of antioxidating substances reinforcing cell and own antioxidant protection, also very, very useful for our cells within our cardiovascular system, therefore still. So I always make sure to provide a good base if I do a constant aerobic work. Obviously, I would want to get it from nature. Sometimes, if I know it's going to be a tough one, then I probably use one of the, like a small amount of supplementation, or supplementation depends. So in addition to that, anti-angiogenic properties of some of these, especially the grape seed extract, can support pathways like VEGF, vascular endothelial growth factor receptors inhibiting proliferation. And this can actually support our cardiovascular system. So the last one I wanted to mention is olive leaf, known as containing over 100 different phytochemicals with at least 12 different, really showing potent antioxidant properties. So, spring clean our cells. So what do we do about it? Well, there are different methods. The first of all, obviously, is starting from a clean diet, whatever that means. Normally, by clean diet, I tend to envisage, first of all, try to reduce chemical coming from the outside. So that's the first. So to me, diet is part of our environment, because obviously it's part of our outside world. And one of the things that I would consider is obviously, especially for certain things, trying to buy organic. Try to make sure that if you don't, you wash it very, very well, or leave it soaking. Maybe adding some, there are products in health shops that can maybe potentially remove some of these chemicals. This is not the day that you're out once a week. I'm talking on an ongoing basis. That can be accumulation of these toxins. Yeah? So given that the basics are taken into account, so are there different colors in the diet, are there different vegetables in the diet, is the microbiome supported well, sleep and etc., then there are other potential mechanisms that can support, in this case specifically, autophagy, as mentioned earlier. So caloric restriction normally has been found, especially for methionine restriction, has been found to support autophagy. I tried to combine that with a ketogenic diet and having intense training, and it has been a rather interesting journey. So one of the things I also want to mention, and I'm just in the process of doing some work on this, making energy from fats converted into ketones is a very efficient way to have a very good ergogenic and less thermogenic output. So we have more power, actually that's not technically correct, but we have more energy coming out with less heat being produced. Imagine the engine of a car. If the right petrol is in there, there is a certain amount of power and not too much heat in the engine. However, if the petrol is wrong, imagine that less power comes out and there is more heat. Okay. In the case of glucose compared to ketones or fatty acids, the fatty acid have less steps in order to end up in energy. So my question is, do our current caloric tables for food have changing meanings? And to me is yes, because if it takes, so a certain food has a certain caloric value, and if it's going to take us less energy to manufacture our output, then obviously we would need to readjust our calculations. I have very empirically worked out that probably to be isocaloric or iso-producing the same amount of energy but is from ketones, that's not a medical term, is at least a 10 to 15%. So my variables on a ketogenic diet, and there are many, my variables trying to maintain the same variables, the same intensity of training on the same amount of calories. If I want to stay and stimulate autophagia and with a ketogenic diet, I have to reduce my total caloric value, in this case coming from fats, some protein, and obviously very little carbohydrates as a net carbohydrate. So this is something for you to consider, because some people, they think they are caloric restricting, but actually they're not. If they are on a ketogenic diet, they're actually isocaloric, because it takes less energy to generate the same amount of energy, so they need to spend less energy to make the same amount. So however, substantial caloric restriction has to be found to promote autophagia, but also increase mitogenesis. And there are plenty of studies. I presented quite a few last year at Shaken 15 in the States. Ketogenic states mimics, to a certain extent, fasting through ketones, and therefore promoting still autophagia and autophagic response. And there are also other benefits, and not everyone is suitable for a ketogenic diet. I took that approach to my nutrition habit and to some of the patient nutritional habits purely because there were potential risks in their health that would warrant a ketogenic diet. So I'm not trying to prove the ketogenic diet works. I'm not interested in that. For certain people, it just doesn't work. And I want to make this very, very clear. But when it works really, really well. And I'm seeing the application in sport. So in addition to that, there are various natural compounds that can also promote this autophagia, like epigallocatechin, caffeine. Be careful with the coffee. Caffeine and coffee. So caffeine is contained in coffee, but some people can react to coffee but not to caffeine. I will probably eventually explain this in more details, but yeah. So anyhow, curcumin increase the level of autophagia. It increases it a lot because there is two increases shown to increase autophagy signaling in cell culture. Environmental stressors such as hypoxia and heat stress. That's the reason why we have autophagia response, sometime training at lactic acid threshold or over lactic acid threshold and stay in that. So high intensity interval training, maybe crossfitting, or for me is judo and karate. These will all help the type of hypoxia. And also heat stress, rebalanced by a cold stress. And obviously redox. Our body functions through challenge and recovery, fasting and feasting. That has been shown, in my opinion, to be probably one of the best ways to maintain health. It's like one doesn't train at all, and the other one overtrains, stroke, under-recovers all the time. Neither of those two scenarios are actually very healthy. So ideally, we want to train very strong enough to make a change in the structure of the body, but also allowing the body not too strong to damage our body and then recovery. This is what I call redox balance. So waste removal, really, really simple and straightforward. First of all, move. Get your lymphatic system, breathe properly, try to do things that helps the body's circulation, and really looking into trying to increase the circulation to remove this waste. So automatically, sedentary lifestyle will be counterproductive. In fact, one of the greatest, I heard the podcast, I think was from one of the guests on Ben Greenfield, I seem to believe, and Ben Lynch also covered it. Ben Lynch is one of my colleagues. So looking at when someone is standing, there is a certain activation of a cardioprotectant, so having a cardioprotectant effect. In fact, first thing I did after hearing that was actually get 2 standing desks, and very, very interesting changes. I don't seem to lose concentration, and I'm constantly adjusting my body. Very, very, very powerful. And obviously these are things like manual lymphatic drainage. So sleep, we mentioned about sleep. Amyloid polypeptides can be one of these accumulation, and there are studies actually pointing that the lymphatic system, which appears to be nearly 10 times more active during sleep rather than when he's awake, is highly important, and this can be activated obviously through a correct sleep cycle. So one of the things I keep tracking my sleep, and I know that there is a certain baseline that I need to hit. Now, sweat, obviously we have people with higher exposure, pollutants, so sweating definitely needs to be very active. You can do that through far infrared sauna. Just careful in the EMF in these saunas, just making sure that they are kind of contained. You don't want to get one benefit and then disrupt mitochondria in another, potentially. So phthalates find twice the amount in sweat compared in urine. So one of the important things, if you sweat either through heat or far infrared sauna or through exercise, make sure that the sweat doesn't stay on the person. So as soon as there is a profuse sweating, if you want to aid it, with perhaps some vitamin C, some really cheap and inexpensive vitamin C, just make sure that that is addressed correctly. So nutritional support for cellular health. Real food, as we mentioned, look at the insulin level, not just the glucose level. So glucose is a marker and is an effect to a certain extent that is reflected into glucose of insulin. So if we consider insulin, then there is an insulinogenic effect of certain protein, as 1/3 can be converted into the gluconeogenetic pathway, neogenesis pathway, not genetic pathway. So high quality toxin-free fats. So you can look that in fish and eggs, and your eggs softly cooked, providing phosphatidylcholine, and some of the. So we are trying to increase the level of healthy fats and trying obviously decrease the ones that are actually damaged, providing also changes within certain epigenetic control if they are denature. Consider either intermittent fasting, which for me intermittent fasting is, for example, intermittent days. I do a 16-8 or 18-6 every day, except when I'm lecturing, then maybe I reduce it, but I call that time-restricted feeding. So either intermittent fasting, time-restricted feeding, ketogenic approach, or a combination of all of them. And I can definitely say that as far as brain health, memory, cognitive performance, I haven't experienced this since my 20s, so something I don't want to give up very easily. Leafy greens for the methyl groups, look at organic liver, look at not actually only organic liver, but offals. If someone is not vegan or not vegetarian, as they're at it, and they know the source of this, obviously try to have as many offals as possible if his taste is okay for them. So looking at reducing factors that would deplete methyl groups, and there is a list that you can quite happily research, like alcohol, detoxifying excesses of neurotransmitters and hormones, diuretics, and so on. So this is PhytoCell, is the one that I normally take prior exercising and or when I travel. Normally, if I'm home, nice, relaxed, my diet is good. Maybe one every couple of days, one capsule only every quarter. It's just an insurance. It's just an insurance that, as you can see, there is grapeseed, pine bark, olive leaf, tocopherols. Please notice there is mixed tocopherols and tocotrienols. So that's the important bit because these are cumulative effects. And these also support collagen. So your bone broth is a great addendum to your bone broth. This is the range that I probably love the most. Folgard, so methyl Folgard, this is your 5-MTHF and B12. I don't have one here with me, but tiny little pot. Dosage can be dosed very, very efficiently. Just a tiny drop is 100 micrograms. I can use it with my son. I can use it. So it's highly upscalable and downscalable. So for an adult, you have 10 drops. For a child, if it needs to be, you can have just a few. Then just methylfolate for people that have plenty of meat with B12, but they don't actually have lots of veggies or lots of green leafy veg. No, I don't tend to use it. And then the methyl multinutrients is 2 a day. That's my multivitamin now. I only tend to take it once a day, so half of those, or once every other day in stressful periods. Then obviously I just, once again, I rather pee out rather than not having there if I need it. And obviously methyl B complex. So to bring it all together, get the basics right. Move, sleep, sweat, and I should add wash. You don't want to sweat and just leave the toxins there, apart from the other side effects that we have if we don't wash. And this is one of the things that get the basics right all the time in order to support the cellular waste. Choose your diet wisely. If there are predisposition for diabetes, Alzheimer's, and certain type of long-term chronic degenerative diseases, you might want to consider autophagia and or ketogenic application. They don't have to be people on a ketogenic diet all the time, but perhaps they can phase it. So they do 2 months and then 1 month and then 3 months and then 1 or 1 and 3, whatever they do. But as long as they see changes in the glucose level and other symptoms, I think is highly beneficial. Lastly, I just wanted to leave you with this: live longer and prosper. Good and poor health is determined at the level of the millions of cells making up our body. Remember the factory, the workers that also support our factory. Optimizing cellular health provides a means of restoring more youthful profile in maturing individuals. I hope you enjoyed it, and the word back